Okay, let's try this question. Find the equation of reflection of this ellipse in the line mirror x minus y minus 2 is equal to 0. हम इस एलिप्स को इस लाइन मिरर में रिफ्लेक्ट कर रहे हैं, हमें रिफ्लेक्टेड कर्व का इक्वेशन निकालना है. डेफिनेटली द रिफ्लेक्टेड कर्व विल बी आल्सो एलिप्स. जो रिफ्लेक्टेड कर्व है वो भी एलिप्स ही होगा ना. कैसे निकालेंगे इस एलिप्स का इक्वेशन? ओके, नाउ व्हाट अबाउट दिस एलिप्स? Center is 4, 3 and axis will be parallel to coordinate axis. We have here a greater than b, so major axis will be parallel to x-axis and minor axis will be parallel to y-axis. So we draw this ellipse on the coordinate plane. Then we draw line mirror x minus y minus 2 is equal to 0. Okay. Now we reflect this ellipse in this line mirror. We have to get the equation of reflected curve. कैसे निकालेंगे? What is the idea? Now we take different points on this ellipse. Okay, all these points will be reflected in the line mirror. When we join all these reflected points, we will have curve ellipse. तो अब मुझे आप बताइए कि क्वेश्चन को सॉल्व करने का आइडिया क्या है. क्या कर सकते हैं? We will consider variable point on this ellipse. Okay, we will find the coordinates of reflection of that point in the line mirror and we will find the locus of that variable reflected point. ठीक है ना? This is the idea. Okay, now what will be coordinates of variable point on this ellipse? We will consider parametric equation of ellipse definitely. ठीक है ना? जब हमें ellipse के ऊपर कोई वेरिएबल पॉइंट लेना है तो हम उसके कोऑर्डिनेट्स को पैरामीटर के फॉर्म में लिखते हैं. पैरामेट्रिक कोऑर्डिनेट्स विल बी 4 plus 4 cos theta, x1 plus a cos theta, comma y1 plus b sin theta. So we have here 3 plus 3 sin theta. Okay. Now we have one direct formula to find coordinates of reflected point in the given straight line. Recall करते हैं वो formula. Suppose image of point x1 y1 in line ax plus by plus c is equal to 0 is x2 comma y2. Image of this point in this line mirror is x2 comma y2. Then we have formula x2 minus x1 upon a is equal to y2 minus y1 upon b. This is equal to minus 2 multiplied by inside bracket ax1 plus by1 plus c upon a square plus b square. ये होता है फॉर्मूला. ठीक है ना? Now suppose reflection of this point in this line mirror has coordinates x2 comma y2. So we have x2 minus 4 plus 4 cos theta upon coefficient of x. We have this equation for line mirror. So coefficient of x is 1. This is equal to y2 minus 3 plus 3 sin theta upon coefficient of y which is minus 1. Okay. This is equal to, we put this coordinates in this expression. Okay. We have minus 2 multiplied by 4 plus 4 cos theta minus 3 sin theta minus 2 upon a square plus b square which is 2. Here 2 gets cancelled out. Okay, and we get here minus 4 cos theta plus 3 sin theta. 4 minus 3 1, 1 minus 2 minus 1, so we have here plus 1. Okay, now from this comparison we get a value of x2. X2 is equal to minus 4 cos theta gets cancelled out. Okay, so we have x2 is equal to 3 sin theta plus 5. And from this comparison, we get the value of y2. y2 will be 4 cos theta plus 2. Now to get the locus of variable point x2 comma y2, we eliminate theta. We use cos square theta plus sin square theta is equal to 1. So we get equation x2 minus 5 whole square upon 9 plus y2 minus 2 whole square upon 16 is equal to 1. And finally we replace x2 by x and y2 by y. So this is equation of reflected curve. ठीक है ना? ये कर्व भी क्या होगा? इलिप्स होगा ना. दिस इज इक्वेशन ऑफ इलिप्स जो हम जानते हैं. अगर किसी शेप को आप लाइन मिरर में रिफ्लेक्ट करेंगे तो शेप तो चेंज नहीं होगा, ठीक है ना, सिर्फ उसका इक्वेशन चेंज होगा अगर हम उसको कोऑर्डिनेट प्लेन के रिस्पेक्ट में देखते हैं. लेट्स ट्राई नेक्स्ट क्वेश्चन. Okay, let's try this question. Find the area of the greatest isosceles triangle that can be inscribed in the ellipse. We have standard equation of ellipse having its vertex coincident with one extremity of the major axis. हमारे पास ellipse का standard equation है. Suppose A is greater than B. So we have this graph of ellipse. Major axis is x-axis. Extremities of the major axis are a1 and a2. Coordinates are a comma 0 and minus a comma 0. अब इस इलिप्स के अंदर हम आइसोसेलेस ट्राइंगल इंस्क्राइब कर रहे हैं जिससे आइसोसेलेस ट्राइंगल का वर्टेक्स इन दोनों एक्सट्रीमिटीज ऑफ मेजर एक्सिस में से किसी एक के ऊपर फॉल कर रहा है. कैसे ड्रॉ कर सकते हैं ट्राइंगल? We have this one possible triangle. Okay, here base of triangle lies to the left of y-axis. We may have base of triangle to the right of y-axis. इस तरह से भी हो सकता है ना. In fact, this is variable isosceles triangle in which one vertex is fixed. It is point A1. Vertices B and C are variable. Okay, we have to maximize the area of this variable triangle. Consider this triangle in which base is to the left of y-axis. Okay. Now vertex B is variable point on the ellipse. So we consider coordinates of point B as a cos theta b sin theta. फिर से अगर हमें इलिप्स के ऊपर कोई पॉइंट कंसिडर करना है, वो वेरिएबल पॉइंट है, तो हम कोऑर्डिनेट्स को पैरामीटर के फॉर्म में लेते हैं. Here theta is parameter, eccentric angle of point B. Then what will be coordinates of vertex C? C is reflection of point B in the x-axis. So coordinates will be a cos theta comma minus b sin theta. Okay. What is length BC? This is 2b sin theta. Okay. M is midpoint of BC. Its coordinates are पॉइंट एम के कोऑर्डिनेट्स क्या हो जाएंगे? a cos theta comma 0. It lies on the major axis, x-axis. Okay. Now what is area of triangle A1BC? Area of triangle A1BC is 1 upon 2 multiplied by BC multiplied by A1M. BC is 2b sin theta. Okay. Now what will be A1M? This is very interesting. A1M क्या होगा? A1M will be A minus A cos theta. ठीक है ना? कई बार स्टूडेंट्स इसको A plus A cos theta लेते हैं, which is wrong. A1M is not A plus A cos theta, it is A minus A cos theta. The reason is here we are considering base of triangle to the left of y-axis, so we will have A cos theta negative. Okay. So length A1M will be A minus A cos theta because A cos theta is negative. If we consider this triangle in which base is to the right of y-axis, in that case also length AM1 will be A minus A cos theta because here the value of A cos theta will be positive. ठीक है ना? तो ये ध्यान रखना है यहाँ पे कि यहाँ कौन सा साइन यूज करना है, ठीक है। ओके, नाउ दिस इज ए बी मल्टीप्लाई बाय इनसाइड ब्रैकेट साइन थीटा माइनस साइन थीटा मल्टीप्लाई बाय cos theta. Okay, now here area, here delta is function of variable theta, parameter theta. So to maximize this function we take the help of differentiation. अब जानते हैं ना, मैक्सिमम मिनिमा के लिए हम डिफरेंशिएशन यूज कर सकते हैं. We differentiate this function with respect to variable theta. We have d delta upon d theta is equal to AB multiplied by inside bracket we have cos theta minus cos square theta plus sin square theta. To find the values of theta for which delta can be maximum, we compare this derivative to 0. Okay. Now we solve this equation. We write sin square theta as 1 minus cos square theta. So we have equation 2 cos square theta minus cos theta minus 1 is equal to 0. ठीक है ना? Now this can be factorized. We have factors 2 cos theta plus 1 multiplied by cos theta minus 1. This product is equal to 0. From this we get two values of cos theta. Cos theta is equal to minus 1 upon 2 or plus 1. We cannot have cos theta plus 1, otherwise theta will be 0. Theta 0 तो नहीं हो सकता. If you take theta is equal to 0, then points B and C will coincide with point A1. ठीक है, ट्राइंगल बनेगा ही नहीं यहाँ पे. So we consider cos theta is equal to minus 1 upon 2, and to ensure that for this value of cos theta delta is maximum, we check the second derivative. We have second derivative test through which we can confirm or verify that this value of cos theta is for maximum value of delta. इसको भी चेक करने की जरूरत नहीं है. Definitely this will be for maximum area. Okay, and how can we get maximum value of delta? For cos theta is equal to minus 1 upon 2, sin theta will be root 3 upon 2. Okay, so we have delta max is equal to AB multiplied by sin theta. I am taking sin theta common. Value of sin theta will be root 3 upon 2 multiplied by inside bracket we have 1 minus cos theta. Cos theta is minus 1 upon 2, so we have here 1 plus 1 upon 2. So delta max is 3 root 3 upon 4 multiplied by AB. So this is required maximum area of the isosceles triangle. ठीक है, तो यहाँ पे भी हमें पैरामेट्रिक इक्वेशन ऑफ एलिप्स हेल्प कर रहा है.